All right, welcome back. My name is Seth Juarez. We're here at the Moscone Center in San Francisco, California for the 2016 edition of Build. I have a special guest here, Anders Hallsberg. How you doing, bud?
Seth, I'm doing well, thank you. Good to see you again.
So we pulled you directly from your session, more or less. What was your session about?
It was about TypeScript.
Of course it was.
What's new in TypeScript? Yeah, what's happened in the last year.
So we were talking a little bit before because we had some time. You essentially have 4 babies, starting with Turbo Pascal back in the day.
That's right.
Are they middle-aged now, Turbo Pascal?
That's a long time. You know, I started in this industry 35 years ago.
That's amazing.
Yeah, Turbo Pascal, I mean the predecessor of Turbo Pascal, I started working on in 1981.
Uh-huh.
Yeah.
I was like 3 years old. I mean, no offense. I was like 3 years old, dreaming of the time I could be a programmer, probably.
Yeah, no, I've been doing it for a while now.
And then Delphi.
Yeah.
And the cool thing about the languages that you've worked on is they were very amenable to tooling. Was that something you did on purpose?
I've always been a pragmatist. You know, I sort of like, not making it any more complicated than it need be, right?
Uh-huh.
And Turbo Pascal and Delphi were, at the core, they're very simple tools, right? With a very simple implementation, and out of simplicity often comes, well, first of all, it's easier to understand,
sure.
and second, it's usually faster. You know, less code tends to run faster, right?
Absolutely.
That's an ethos that's worked well for me, at least. Yeah.
Awesome.
So.
And then we go to C#.
That's right. Yeah. So I came to Microsoft 20 years ago.
Wow.
It's in '96. So that's 20 years this year.
So it's not the 20-year anniversary of C#, but close to it. I mean, it's a pretty old language.
Yeah. We started C# probably in '99. You know, we went public in 2000.
Of course.
So yeah, the language has 16 years on it now.
It's a teenager.
Yeah, it is. It is. Sweet 16.
Sweet 16. Then C#, and then finally, we've come upon sort of this time where the web has become sort of this ubiquitous thing, and it turns out that we landed on JavaScript as the way to express functionality on the web.
That's right.
And there were some inherent problems with it, or maybe there wasn't.
So today, the world has become very heterogeneous,
of course.
As we all know. All these different mobile platforms, the web, like the cloud, and really the only one language that runs everywhere, when you count the browser as well, is JavaScript, right? And the world knows that. And JavaScript has a lot of faults. You know, it was conceived very quickly in 3 weeks, back in the mid-90s. But you know, behind those quirks is actually a very beautiful language, you know, but it may need some help in teasing it out, right? And
I see.
And so the TypeScript project really has been all about, sort of us realizing that JavaScript was going to be big, but also realizing that JavaScript really lacks several things that you need for medium to large scale application development.
Right.
And that is basically in a nutshell the problem that we set out to solve with the TypeScript project. And we've been at it now for, TypeScript, this is the 5th year, so probably this summer it'll be the 5-year internal anniversary for the inception of the TypeScript project, yeah.
And that's interesting the way you phrase it, right? Because the phrasing, you were very specific. You said, when you're working on a medium to large project, there are some things that need teasing out, right?
Yeah.
I remember the first JavaScript I wrote was an image rollover.
If you're going to write 5 lines of JavaScript, or 10, or even 100, you may not need big tools. You don't need necessarily statement completion. You can look it up, or you know exactly what. But if you're going to write 100,000 lines or 1 million lines of code, you really need some help.
Right.
There's no way that you're going to find all the bugs in 100,000 or 200,000 lines of code, in any kind of humanly countable time period, right? You need help. You need tooling. And that's really what TypeScript is about, is like adding the things to JavaScript that's missing for large-scale application development, but adding them in a way that doesn't compromise the cross-platformness and the beauty of JavaScript, if you will. And so TypeScript is an optional static type system. It's a superset of JavaScript that has optional static types but those static types exist only at compile time. And then the compiler removes them and just emits JavaScript. And it's built as a superset of JavaScript. So it starts with JavaScript and it ends with JavaScript, but in the middle is a higher level experience.
Sure.
That with static types that allows us to build better tooling so that we can give you features like statement completion and safe refactorings and code navigation and all the things that you need when you're writing large code bases.
So you mentioned some of those things, like large code bases, and you sort of mentioned a couple of them in passing. You mentioned that static typing allows you to do this, this, and this. What are some of the biggest things that you think TypeScript brings to the table in these medium to large projects? And let's get into them specifically, so developers sort of really get a sense of why it's a good idea. Maybe it's not a good idea to use in your project, but for these reasons it is. What would those reasons be?
Well, I think that there's one overriding reason for all of it, and it's called productivity. It allows you to actually be productive in large JavaScript code bases. Now, that breaks down then to different kinds of productivity, right? There is like productivity that you get from being able to use the very latest ECMAScript 6 features and have us down level compile them so it can run in older browsers that don't yet support them.
Sure.
There's productivity that you get from having tools like statement completion and refactoring and so forth. There's productivity that you get from having the compiler find the errors instead of you having to find the errors when your program runs, right? And then there's actually like productivity that comes from having your code document itself. When you start writing down the types in your program, you're in a sense also writing the documentation for the program. And this is part of the reason I think why we're seeing frameworks like Angular and a bunch of other frameworks now like Ionic and you know, jump onto TypeScript. Because they realize, well, gosh, we're writing a framework. When we're writing a framework, A, we got to make sure that the code is correct. And B, we got to write documentation for it. Well, what better way to write the documentation than actually write down the types in the code, right? I mean, so that statement completion can serve it up for you again, you know, based on that. And so there are a whole bunch of things that contribute to this overall thing called productivity. Right?
So when we're talking about writing down the types, these types are not necessary once you transpile down or compile down the JavaScript.
Right, they completely disappear. And so there's no overhead from having them. They only exist at development time, and then poof, they vanish. When you compile, you're just left with the JavaScript.
That's amazing. All right, so I talked to you last year about TypeScript. Maybe we should get like a state of the union. What has happened since then to now? And then you also in your talk had some brand new things that you went on. Let's go through those things.
So in the last year, we have shipped 4 releases. We tend to, it's a very fast-moving team. We all work you know, in the open source way and the open development way. The whole project is hosted on GitHub, and we tend to iterate, produce releases every 3 or 4 months. So we released 1.5, 1.6, 1.7, and 1.8 in this past year, and going from, you know, having rudimentary support for ECMAScript 2015, which is ES6 renamed, to now having complete support for that, and also we're starting to check off now features from ECMAScript 2016 and 17, like async await, for example, that we're supporting now on the server, and we're working on supporting that down level. And then we've also worked a bunch on just adding more capabilities to the type checker. And that was one of the things I showed today, like that's coming in TypeScript 2.0 is non-nullable types, which and control flow-based type analysis, which takes you to yet another level of reasoning by the compiler and another level of guarantees that we can provide about your code when you're writing it, because we can now ensure that if you said this is not supposed to be null, well, we can ensure that it never is, or we can tell you why it is.
So the nullable, I mean, nulls cause a lot of problems.
Yes,
so
it's Tony Hoare called it his $1 billion mistake, right? That it was so easy to implement, and he figures it's cost the world at least $1 billion in lost time, right?
That's amazing. And so the other one you mentioned, because nullability checks is, I mean, it's pretty easy to understand as a dev, that if you mark a type as not nullable, the compiler will tell you, it's null. It's going to be null here. You should fix it. But what about, you said control flow? Did I understand that right?
Control flow, but yeah. So you realize that once you do the non-null types, it becomes a big pain you can't just have non-null types, but then how do I then access a property on this object if it can be null? Well, the type checker has to somehow know that you've proven to it that at this point it isn't null. Mm-hmm. And you can do that by, let's say, for example, you say if x not equal to null, x dot something. Well, the type checker can look at the surrounding context and see that, oh, you just checked whether it's null, so therefore we can now treat it as if it isn't null inside that if statement.
So it's more of a semantic layer.
So yes, but then in order to really do that, you have to do full control flow analysis. You have to look at what are all the possible code paths that could lead to this point in the program, and what kind of checks were made along all of those paths, and how do those checks affect the type of X right here? And that's the reasoning that the compiler is now doing.
So when you talk about control flow, it's not a developer needs to do this, it's something
the
compiler's doing.
This is something the compiler does
to make nullability checks work.
When it analyzes your code, yeah.
That's amazing. All right, so there is actually a question about that.
Uh-huh.
Flow control type deduction is awesome. Will it come to C#? and C# misses you apparently. It's like your teenager. It's like, where are you at?
Well, I'd like to go where opportunities present themselves,
sure.
and there's a big opportunity I felt in this JavaScript space, and I think we're having a lot of fun, and I think we're really helping people on this project. So I'm going to stick with that for a while yet. But absolutely, a lot of the things that we're learning from the control, and C# does a lot of this analysis already, mind you. Like definite assignment analysis is basically a subset of what I'm talking about here, right? So a lot of that reasoning is already in there. But there's more that could be done, and sure, we're going to look at other ways to apply this, yeah.
And I think Mads is going to be on later on to talk about C# and other things. And I did an interview with him where he's looking at the same kind of nullability stuff that's coming into TypeScript.
Yes. This is a problem for everybody.
All right, so here's another question. It's a long one.
Yes.
From the Bitbender, you showed in the demo how TypeScript massively improves tooling, statement completion, finding errors during compile time. Does debugging also work like we know from C#? That you single step through TypeScript code, see variables. He's asking, is it like C# when it comes to debugging?
Basically, yes. I mean, one of the capabilities that we have in TypeScript is the ability to produce source maps. And source maps, when you have a language that targets JavaScript, but when the actual source code that you're working in is a different artifact, you can produce these maps that say, well, line this in this program here corresponds to line that in the output JavaScript. And then the debugger uses that as a reverse mapping to allow you to single step through the code you wrote.
Right.
Even though the line numbers are different and the scopes of variables. And so source maps are the enabler for that, and we fully support source maps.
So when you're debugging and F10ing, so to speak, you're going through the TypeScript code.
Yes.
That's awesome.
Yes. Now, sometimes we have to inject temporary variables or rename variables or whatever, if because like you're compiling down level and the down level version of JavaScript doesn't. Yes, and that. So sometimes they're like little quirks, and we're working on making them better, But generally speaking, yes, you can expect to have the same experience.
That's awesome. All right, next, are you considering adding to TypeScript such features as pattern matching or algebraic data types? What do they mean by pattern matching and algebraic data types, for those who might not know?
Well, so those are features that come from functional programming languages like Haskell or Camel and F# and so forth. And it's basically the ability to match on the shape of a type and say, well, I'm not going to explain fully here, but yes, we're looking at it. Now, a lot of what we do is sort of already there. The work that we're doing with union types and string literal types, and we're also looking at doing numeric literal types, and that would allow you to build, almost the equivalent of abstract or algebraic data types. Although it's going to look different, but it'll have the same capabilities. Also, there is work underway in the JavaScript committee to add pattern matching to JavaScript. And of course,
To add what?
pattern matching to
cool.
JavaScript, yes. In fact, Brian Turlson, who's our representative in the ECMAScript standardization process, is championing that particular proposal. So, and we obviously talk. So yes, as that makes its way in and gets to a higher stage, there are all these like stage 0 through stage 4 of standardization. And once it gets to a high enough stage, we're gonna start looking at it, yeah.
All right, so there's a couple of questions that I have, and then we'll get back to these questions. It feels like the world figured out, oh man, JavaScript is important, and now we're sort of iterating on the language at a much faster clip. Is that the case?
Yes, is the short answer. Yes, I mean from ECMAScript 3, the ECMAScript 5 I think was ratified in, I forget, it's like 6 years between ECMAScript 5 and ECMAScript 6, I think, and now they have basically said that we want to be on a, and before that it was 10 years between ECMAScript 3 and 5. But now the committee wants to be on a 1-year cadence, but with smaller releases. So there's already an ECMAScript 2016 being ratified currently. It doesn't have a whole lot in it, like it has the exponentiation operator and a few other things. And async await was slated to go in, but missed the window, and it'll probably be in ECMAScript 2017. And so we're just going to see smaller, but more often.
Okay, and then the other question that I had was, whenever you're compiling, or is it compile the right word? Is it transpile? I mean, does it matter?
It's 2 words for effectively the same thing, it's a compiler.
Okay.
It just so happens that the output is source instead of bytecodes, but
it is what it is.
But it's still a compiler,
So the question that I have, just to go along with that, is it drops some file. Like there's a d.ts file. You talked about the source maps. What is the thing? What are the artifacts that the compiler is generating, and what do they do? Because I see these files in there, and maybe people don't know what they do.
Well, I mean, so you typically write in TypeScript, you write a bunch of TS files, and then when you compile, we produce. Well, one mode is we produce one JavaScript file per TypeScript file. Another mode is you say, you can either put them next to the TypeScript files, you can say, put them in a mirror directory structure over here.
Right.
And so you get JavaScript files over here and TypeScript files over here. We can concatenate them into one file in certain cases, or people use bundling tools like Webpack or Browserify to package up their code. If they're using modules, you can package it all up. I showed that in my demo today, using Webpack in a React program to just package everything into one file. So there are many different ways you can package. And I think one of our core principles is to be a good citizen in the JavaScript ecosystem, in the JavaScript toolchain, because people tend to have tool chains. Like when they string together, they may have some CSS tools, they have some module loader packaging tools, they have a variety of linters and whatever, and you just sort of want to fit into that workflow.
Right.
In as many ways as possible. And we're very cognizant of that, and we're trying to, fit in.
I mean, with all due respect, how do you do that? I mean, because when you say Browserify and Webpack, I'm thinking Grunt and Gulp, which is now not the thing anymore.
No, that's different. Grunt and Gulp are build tools.
Okay.
Yeah.
And
Browserify and Webpack are packagers.
Okay.
Yeah.
So how do you know when a new tool comes out? How do you make that fit in? And see, because even me, my understanding of what those things do is a little...
I think the only way you can do this is listen to the community.
Right.
What do people ask for?
Yeah.
And we were getting a whole bunch of asks for, bundling support and whatever, and then you go there, and like nullable types or non-nullable types, that's been one of our top requested features, and so, hey, we got to go do it. Yeah.
All right, let's go for some next questions. When will NPM for type definitions be ready? Are we going to have like a repository?
We're targeting, well, and I talked about that in my talk, and there's a slide that gives a little more detail. We're basically looking at using NPM as the package manager, not just for your JavaScript code, but also for your type definitions.
Right.
Now, we already support the ability for a node module to to supply its own type definitions. In fact, Angular does that.
Right.
So you don't have to install types separately. It comes with Angular. It comes with RxJS. It comes with a bunch of popular things out there. But for those that don't, we still want to use NPM as the installation mechanism, as the cataloging mechanism, and also we want to use NPM to handle installation of all of your dependencies. Because part of the problem, and part of the real problem that a package manager solves, or one of the real problems it solves, is dependency management.
Right.
Instead of you shipping this along with all of your dependencies, you only ship your thing, and then you say what you depend on. And then they in turn depend on, and then the package manager puts it all down on your box. So you don't have to like ship all this duplicate stuff and then end up with version conflicts when someone else has a different, you know what I mean? So you need someone to reason about that. And really, the rules by which you want to do that reasoning shouldn't be different just because it's type declarations.
Right.
And so we want to fit into that. And we're looking at doing this for 2.0.
Okay.
So this is like in the next 2 to 3 months.
And by that you mean we're going to put our type definitions into NPM, and you can
Well,
just put them in
what we're going to do is we're going to basically document a preferred way of writing these things, and if you want to put them into NPM yourself, you can. We will also automatically scrape definitely typed, which is where everyone keeps their DTS files now, and automatically produce NPM packages for everything in there. And so we'll run some analysis on all these declaration files, and then, for all of the ones where we can do it automatically, we will just do it automatically.
Right.
And otherwise, we'll point out to the community, here are the ones that we can't auto-generate, but if you fix this and that, then we can auto-generate it for you. And so ultimately, we'll get there pretty quickly, I think, where it becomes an automatic process. You just put it on definitely type, or wherever we decide that the ultimate catalog is, right? And then poof, automatically NPM packages appear.
And that's nice because it doesn't interrupt, again, the flow of someone that's already done something on definitely type. It's just something we just move over to NPM.
Yeah, no, we want to, obviously a lot of effort has gone into definitely type by the community.
Right.
And we want to make sure to maximally leverage that so people don't have to go redo everything. Yeah.
All right, so next question. Any tool hint to generate TS classes from C# classes of DTOs and like models?
I think there are actually some open source tools out there that do that already. I don't remember the names, but I think there's something. Yeah.
It feels like you could do something with Roslyn too, pretty easily.
Oh yeah. No, I mean there are many ways you could do it. Yeah. But I think something already exists.
All right, so the next one is, do you have any ideas to improve JS doc?
I can't say that I do. JS doc is a bit messy. There's no authoritative specification for JS doc. There are sort of many dialects of it. Google Closure uses one dialect, but some of the documentation generators use other dialects. I think for us, you saw the work that I demoed today with Salsa, which is using the TypeScript compiler and language service to analyze JavaScript. And in there, we now support JS doc.
Interesting.
But that's probably as far as we're going to take it. I think our recommendation is that if you're going to use static typing, you really ought to write type annotations.
I see. Because I mean, it's like if you're already going to do that, you might as well just take that extra half step.
But I do think, JS doc certainly is useful for writing the documentation bits.
Sure.
It's just, it's not the greatest place to host a type system.
Got it. All right, next question. Thanks for TypeScript, number one. Thank you. How could a floating point error be fixed? Like 0.1 plus 0.2 equals 0.3004.
Well, of course.
Of course it does.
Did you not know that?
Oh, yeah. I mean, it doesn't. In America, we only have math. Everywhere else,
I
we have
actually
maths.
think there is currently a proposal being championed, I think, maybe even by Brendan Eich, for adding BCD encoded, I'm not sure if it's BCD encoded or what it is, but decimal encoded floats.
Oh, interesting.
Or floating, yeah. And so C#, for example, supports a decimal type,
which
uses a base 10 encoding internally, and that basically gets rid of all the
gets rid of the
rounding errors, right, and the truncation errors. that all come from trying to represent accurate base 10 numbers in base 2, where
Right.
they are infinite fractions.
Sure,
So,
sure.
Yeah.
All right, next, difference between Elm, ELM, and TypeScript. I don't even know what Elm is. Maybe you know.
I'm not super familiar with Elm, so I'm going to have to owe you an answer on that one.
Yeah.
I'll go look at it.
Yeah, absolutely. He's a good guy to know this. Next one, are you considering adding to TypeScript some functional features like Curry and Compose?
Well, I mean, they're there. I mean, you can curry currently. I mean, you
yeah,
do so.
Functional.
I mean, TypeScript its type system is actually quite an advanced type system. We do support a whole bunch of genericity. We have union and intersection types. We have very rich type inference, and things like currying and whatever. I mean, we support lambdas. You can just curry any function you want. I mean, that's and we can pretty much infer the type. So
That's awesome.
So most of it is there, I think, unless there's something in specific I'm missing. But
All right, and then the next question, any plans on providing compile time features like name of operator?
possibly, although we may not do it the same way that C# did
Sure.
it. But I understand the scenario. Yeah.
So moving forward, we have about maybe 3.5 minutes left. Where do you see TypeScript going? Is it going to continue to just stay ahead of what you see what I'm saying? Because right
Yeah.
now what we're doing is we're saying we're putting features from the future versions of JavaScript in, and we're adding some static
Right,
typing.
right.
Is that still the current trajectory? Is there something different?
I think that's our playbook currently, and we're gonna certainly stick with that. I mean, because as I mentioned earlier, ECMAScript is going to continue to evolve.
Right.
And there will always be this JavaScript feature gap between the latest and greatest that you want to use
the
when you're
browser.
coding and the actual thing that you can assume is present in the browser.
Sure.
And that gap needs to be filled by something.
Right.
And TypeScript is a very good answer for that something. And then along with it, you also get all of the tooling advantages that you get from static typing, and that, so I think that's a great formula, and that's one that we're gonna stick with for sure. Yeah.
So what are some things that you're thinking of adding, or how is JavaScript evolving, and how is TypeScript going to get evolved with it? So I guess I'm starting to look at now, what does it look like, TypeScript in the future?
So we talked about a few of them here, like async await, pattern matching are some of the things that are interesting and on the radar that we certainly will look at as well. There are still things that we could potentially do in the type checker and the type system. We certainly know that we would like to provide many more refactorings than we do. We only provide one,
Yeah.
rename. That's arguably the most important one.
Right.
But there are many more that we could do that we simply haven't had time to do. So lots of stuff we could do there. So there are many, many things.
You talked a little bit about sort of the community and how they're sort of helping TypeScript evolve and sort of helping with the trajectory of it. Tell us about how people can get involved community-wise with TypeScript.
Okay. I would go visit our GitHub site.
Right.
The entire team lives there every day. And if there's something you'd like to see, open an issue. Someone will jump on it, I guarantee you, within no time, and engage in a conversation about it. And if it's a good idea, maybe we'll do it. Or maybe someone in the community will do it. It's really a lot of fun to have this close interaction day to day with your user community. It's something I really, really enjoy. And it makes the product better. It really does.
And it's different than what we've done traditionally. What are some of the things that sort of the community has brought to your attention that you're like, oh, wow, I would have never thought of that?
Well, I mean, I don't even know where to begin. I mean, there's
that many.
Practically every feature we do has some start somewhere in the community. Has been asked for.
Right.
Asked about. The community has built, for example, like the plugin for the Atom editor is entirely built by the community. A guy named Basarat is doing a wonderful job on it, and it's a great piece of engineering, that just came out of the organic open source community.
That's awesome.
It's
so
wonderful, yeah.
we have about 30 seconds left. Let's just say someone's watching this and they're like, okay, I'm sold. I have a pretty large JavaScript application that's causing me grief, and I'm having problems with tooling, and I can't keep track of anything, and if they're getting these smells, where can they go to start sort of looking at TypeScript and then moving stuff over? Because
Sure.
you can do it incrementally too.
Yeah.
How would you suggest someone get started?
Start at typescriptlang.org That's our site, which was just recently spiffed up and looks very nice now. There's a bunch of documentation there, links to other places. But just go search also, you'll go to our GitHub site. I would definitely recommend that.
Awesome.
There's lots you can find there, yeah.
Well, it's always a pleasure being with you, my friend.
Likewise.
Again, thanks so much for being with us. This is Anders Halsberg on TypeScript. We are going to see you after the break with Amanda Silver. Thanks so much. We'll see you next time.